Imagine this. It is exactly 9:59 a.m.
The absolute most stressful minute for literally any founder.
Oh, completely. You have poured months of your life, millions of dollars in venture capital, and just endless sleepless nights into building this ultimate hyper-modern e-commerce startup.
Right. The stakes are massive.
Exactly. And at 10 a.m., you are dropping a highly anticipated limited edition sneaker.
The ultimate hype drop.
Yeah. So the clock strikes 10, 50,000 eager customers hit add to cart at the exact same millisecond.
And we all know what happens next.
Yep. Instantly, your site crashes. The screen just goes white. Millions in revenue simply vanish into the ether.
It's just brutal.
It is. And the reason why, well, it's not because of some silly bug in your code. It's actually because of a fundamental hardware design flaw drafted in the wake of World War II. So welcome part 1 of a 5-part R&A's Deep Dive series.
The Genesis Project, creating an e-commerce site.
And the title to today's deep dive is The Engine of Logic.
I love that title.
Thanks. We have a very specific mission today for you, the listener. Because before we can even talk about building this massive platform, we have to start at the absolute bottom.
Right. Before we look at sleek user interfaces or, flashy marketing algorithms.
Or cloud infrastructure, yeah.
Wow.
We have to understand the absolute baseline mechanics of computing. We're talking about the core academic deliverables that govern literally every single transaction that will ever take place on your site.
The foundation.
Exactly. If you're aiming for CS Level 111 mastery, this is the ground floor.
Because the reality that every startup founder really needs to face is that every sleek, modern mobile transaction you make is tethered to the past.
Like every time you tap your phone to buy a coffee.
Yeah, or order groceries, stream a movie, whatever. It is all tethered directly to a physical blueprint from 1945. Think about that deeply for a second.
It's kind of wild to think about.
It is. We are layering hyper-modern, instantaneous commerce expectations over mid-20th century architecture.
Right.
And understanding how that 1945 blueprint physically moves data is it's the only way to architect software that prevents those catastrophic system failures when your startup finally goes live.
Okay, let's unpack this.
Yeah.
Because framing modern mobile commerce as a prisoner to 1945 architecture is a pretty bold claim.
It sounds crazy, but it's physically true.
Right. So to understand how our hypothetical e-commerce site processes a customer's order, we must first look at the foundational architecture that handles data.
The bare metal.
Exactly. There is a universal 4-stage cycle that governs everything a computer does. Input, storage, processing, and output.
The bread and butter of computing.
Right. Now, I know you as a founder are familiar with the basic concept of a computer taking an input and giving an output.
Sure, you press a button, something happens on screen.
Yeah, but we need to look at the physical reality of how that actually happens under the hood.
Precisely. And that physical reality is what we call the von Neumann architecture.
Named after John von Neumann.
Yeah,
right.
Exactly. He formalized this design way back in 1945. And before this, computers were basically these massive room-sized calculators.
Like those old black and white photos with the giant cables everywhere?
Yes. They literally had to be physically rewired by hand by human operators just to run a completely different program. It took days.
Wow. So von Neumann comes along and just changes the game.
He introduced a massive paradigm shift, and it's one that we have been living under for nearly 8 decades now.
So what's the defining characteristic of his blueprint?
Well, it's specific and it's highly consequential. The architecture dictates that both the instructions, meaning the program itself, and the data, the information the program is acting upon, must share the exact same physical memory space.
Wait, so we're talking about taking the software rules for our storefront and the actual customer credit card data and housing them in the exact same physical neighborhood inside the machine.
Yes.
That seems crowded.
It is. And while that shared memory structure was revolutionary at the time because, it allowed computers to be easily reprogrammed without moving physical wires, it is literally the DNA of modern computing today.
Right.
But if we look at the systems implications for your e-commerce project, it forces us to question what I can only call a massive degree of engineering hubris in the tech industry today.
Engineering hubris. I love the sound of that, but break down exactly what you mean by hubris in this context.
Well, think about the scale of what you were trying to build here. You are designing a global digital storefront.
Right. We want massive scale, instantaneous response times.
Exactly. You want thousands of concurrent users interacting with high-definition assets. And yet, the underlying assumption of the entire tech industry is that we can confidently run these sprawling, wildly complex platforms on a 70-year-old logic gate system.
So we haven't fundamentally changed the blueprint since 1945.
Not really. We have essentially just taken that 1945 room-sized computer and shrunk it down to a microscopic scale.
Oh.
We haven't changed the layout at all. We've just made the components smaller and faster. We are asking an architecture designed to calculate missile trajectories in the 1940s to flawlessly manage global, instantaneous mobile commerce today.
I have to challenge the efficiency of this model, partner.
Please do.
Because when you say shared memory space, my mind immediately goes to the physical logistics of that. Let's make this tangible for the listener.
I love a good analogy. Let's hear it.
Is this 1945 shared memory standard basically like running a massive high-end restaurant where the recipes, which are our instructions, and the ingredients, which are our data, are shoved into the exact same tiny pantry?
Yes, that is exactly the visual you should have in your head.
Because if we play that out, if the master chef needs to know how to make a complex dish, they have to physically walk into that pantry to get the recipe card.
Right.
But then they also have to go back into that exact same crowded pantry to get the tomatoes and the onion.
Over and over again.
How does that not lead to absolute chaos for a startup? You're constantly reaching into the same physical box for two entirely different types of things just to complete one simple user transaction.
It does lead to chaos, or at least, it creates a massive logistical hurdle. And that potential for chaos brings us to how the actual hardware of your server tries to manage the flow of traffic.
Right, because someone had to direct all this.
Exactly. To prevent our metaphorical restaurant from burning down, we have to look at the exact mechanisms inside the machine. Let's look inside the hardware by tracing a real-world scenario on our e-commerce site.
Let's do it. Because to understand how we manage this shared pantry, we have to break down the anatomy of the CPU, the central processing unit.
The heart of the machine.
Exactly.
Mm.
Now, connecting the CPU, our kitchen, to that shared memory pantry is a physical and electronic backbone known as the bus.
And we really should clarify what the bus actually is in a physical sense. It's not abstract.
Right, it's not just a software concept.
Not at all. It is a series of microscopic copper traces etched directly into the motherboard. It is a physical conduit that electrical signals must traverse.
It is the single, narrow hallway connecting our kitchen to our pantry.
Perfect way to picture it.
Now, inside the CPU kitchen itself, we have a few critical components to manage this. First up is the control unit, or the CU.
The traffic cop.
Right. You can think of the CU as our traffic policeman, or the lead expediter in the kitchen. Its entire job is to manage what we call the fetch-execute cycle.
Fetching the data and executing the command.
Exactly. It directs the flow of data, fetching the electrical signals representing instructions from memory, and then orchestrating their execution.
And the reason it's a cycle is because it happens sequentially over and over billions of times a second.
Right.
The CU has to ask, what's the next instruction? Wait for it to travel down the narrow hallway of the bus, read it, and then execute it. It's inherently limited by how fast those signals can physically move back and forth.
Exactly. Then we have the registers. These are tiny, ultra-fast storage areas located directly inside the CPU itself.
Way faster than the main memory pantry.
Way faster. And the most important one for our e-commerce purposes is the accumulator.
Ah, the cutting board.
Spot on. The accumulator acts as the primary workspace. If the memory is the pantry down the hall, the accumulator is the cutting board sitting right in front of the chef.
Makes sense.
It holds the active data being worked on in that exact microscopic moment in time.
Right. It saves the chef from having to run all the way back to the pantry just to hold a tomato while they look at the recipe.
Right. And finally, we have the ALU, the arithmetic logic unit.
This is the actual master chef.
Right. This is the chef. This is the part of the CPU that actually does the heavy lifting. The ALU is a complex arrangement of microscopic logic gates that handles all the math, like addition and subtraction and all the logical comparisons.
So when your site checks if a user's password matches the database, or if the sneaker inventory is greater than 0 before allowing a checkout, the ALU is doing that physical logic.
Exactly. It's routing electricity to make those decisions.
What's fascinating here is, how these distinct physical pieces orchestrate what feels like a seamless, invisible user experience.
It feels like magic to the user.
It really does. To really cement this for you, the listener, Let's walk through a calculated discount scenario for your e-commerce site. Let's trace the journey of a single piece of data through this 1945 architecture.
Okay, lay it on us.
Imagine a customer is on your checkout page, about to buy those limited edition sneakers. They type in a 20% discount code.
A completely standard feature for any online storefront.
Entirely standard. But let's look at the electrical reality. First, we have the input stage. The customer taps that code on their smartphone screen.
Right.
That tap generates an electrical signal that travels through the network and eventually reaches the CPU of your server. The control unit, our traffic policeman, springs into action.
Waking up the kitchen.
Exactly. The CU sends a signal down the physical copper traces of the bus to our shared memory pantry, fetching the specific instruction that says, hey, we need to execute a percentage discount on the current cart total.
It's retrieving the specific recipe for applying a discount.
Exactly. But it also needs the ingredients. So the CU sends another signal down that exact same narrow hallway to fetch the cart total.
Then brings it back.
Yes. Now we need a place to do the actual work. So the accumulator, our cutting board workspace, takes hold of the current subtotal of the sneakers. Let's say it's $100.
Right.
The accumulator is actively electrically holding that $100 value.
It's prepped and ready on the cutting board.
Now the ALU steps in. The arithmetic logic unit receives the instruction from the CU, looks at the $100 on the accumulator, and physically performs the mathematical subtraction by routing electricity through its logic gates.
It does the math.
It calculates that 20% off and reduces the value. Once the ALU has done the math, the new price is generated, which leads us to the final stage. Right. The new discounted price of $80 is sent back over the network and displayed right there on the customer's screen. Input, storage, processing output, screen, CU, accumulator, ALU, screen.
Here's where it gets really interesting.
Oh boy.
Because that step-by-step logic you just outlined is beautiful. It is an elegant, incredibly precise mechanism.
It's a marvel of engineering, truly.
It is. But it works perfectly for a single customer calculating a single discount in a perfect, frictionless vacuum.
Which is never the reality of a startup.
Never. As the lead architect of this startup, you have to ask a highly strategic, business-critical question. What happens to that physical copper bus when 50,000 customers hit that exact same apply discount button at the exact same millisecond?
And now we have arrived at the fundamental vulnerability of the entire system.
Because it's not a software problem anymore, is it?
No. You are no longer dealing with a software problem. You are dealing with a physics problem.
That exact scenario, thousands of simultaneous requests, exposes the fatal flaw in the 1945 design. It brings us to a massive friction point that will literally dictate whether your startup survives its first major launch.
The breaking point.
Exactly. It is a phenomenon known as the von Neumann bottleneck.
And to understand the bottleneck, we have to look at the disparity in speed between our kitchen and our pantry.
Exactly. Because remember, our foundational rule, both the instructions and the data, are forced to travel along the exact same shared highway, the bus.
And modern CPUs, our master chefs, operate at mind-boggling speeds.
And ALU today can perform billions of calculations a single second.
Billions. But the physical memory, the pantry, is relatively slow to access. Fetching data across the motherboard might take hundreds of clock cycles.
So your hyperfast chef is standing there, knife raised, absolutely ready to chop a billion tomatoes a second.
But they have no tomatoes.
None.
They are completely starved for ingredients because the waiter has to slowly walk down that single narrow hallway to get both the recipe and the tomato one at a time.
The processor just sits there idling, wasting time, waiting for the data and the instructions to squeeze through that single shared bus.
The bottleneck isn't about the CPU lacking power, it's about the physical delay of moving electrical signals across space.
Right.
If we connect this to the bigger picture, this bottleneck is directly tied to the ultimate nightmare for an e-commerce site that we mentioned at the very beginning.
The 10.000 sneaker drop. The flash sale.
The moment of truth for any modern brand. This is where startups live or die. You have spent millions hyping up a product.
You have a highly limited run of inventory. You've promised total exclusivity.
And at exactly 10:00 a.m., the product goes live. You don't have one customer entering a discount ad. You have 50,000 people clicking add to cart simultaneously.
And every single one of those clicks generates a fetch execute command.
Exactly.
So what exactly happens inside the machine when that massive wave hits? Walk us through the failure cascade.
We see a complete and total systems breakdown at the hardware level. Because the bus is flooded with customer requests, a massive electrical traffic jam occurs in that narrow hallway.
Right there on the motherboard.
Yes. The control unit is desperately trying to fetch the instructions for how to update the database, but the bus is entirely clogged with the incoming data of 50,000 credit card numbers.
What's the ALU doing?
The ALU is sitting there, perfectly capable of doing the math to deduct inventory, but the accumulator is empty because the data simply hasn't arrived yet. The highway is gridlocked.
The waiter and the sous chef are just crashing into each other in the hallway, dropping plates, and no food is making it to the kitchen.
Precisely. And because the hardware is gridlocked, the software starts to panic.
The database queries time out because they take way too long to resolve.
The web server stops responding to new requests because its queue is full.
And ultimately, your customer sees a white screen, a 504 gateway timeout error.
And they take their frustrations straight to social media, destroying your brand's reputation in minutes.
It's terrifying.
It really is. What I really want you to understand as you build this project is that scaling a startup isn't just about having brilliant marketing or writing perfectly clean code.
Or designing a slick user interface, right?
Right. It is about deeply understanding and anticipating when your digital highway will literally run out of lanes due to these rigid physical hardware constraints from 1945.
So my co-host, if I'm hearing you correctly, the danger is fundamental to the medium itself.
It is built into the floor plan.
No matter how fast our mobile apps feel to the user, no matter how brilliantly optimized our software is, we are always held hostage by this hardware bottleneck.
Always.
It is exactly like having a massive, modern, billion-dollar stadium filled with tens of thousands of eager buyers, but forcing every single one of them to enter through a single, rusted turnstile from 1945.
That is the exact reality of the von Neumann architecture under heavy load. The turnstile can only spin so fast, no matter how badly the crowd wants to get inside. So what does this all mean for you, the listener? Embarking on the Genesis project, it means that building a successful e-commerce site requires a profound respect for the physical limits of the hardware your software runs on.
Respect for the physics.
Exactly.
Bob?
You can have the greatest vision in the world, but you cannot outcode the physical constraints of the bus. You cannot ignore the anatomy of the CPU, the limits of the accumulator, or the shared memory reality of the von Neumann design.
You have to work around it.
Right. To succeed, you have to architect your software in a way that aggressively mitigates that traffic jam. You have to utilize caching, load balancing, and distributed systems to essentially build multiple turnstiles.
Keeping as much data as close to the CPU as possible so it rarely has to use that slow, crowded bus. This raises an important question, and something I want you to really mull over as you design the foundational architecture of your platform. If the engineering hubris of today is heavily relying on a 1945 hardware blueprint to sell modern sneakers to millions of simultaneous users, what will be the radical architectural shift required to finally break the von Neumann bottleneck and unleash the next true era of digital commerce?
That is the million-dollar question.
Thank you for joining us, and we look forward to continuing this journey with you.
Keep exploring. Expand your mind.